수업하시게
그러면
해볼까요?
좋죠. 네,
한번 가보겠습니다.
예. 예.
이제 잘 되세요?
예.
오늘
다시 끊기면 제 방으로 오시든지 우리 문지우 씨 TA가 그 옆방이 되니까 그 방에 가서 하시든지 그러세요. 일단 계속해 보시고요.
활성화를 시켜야 되겠는데요?
코어 스트에 달아야 된다고?
네.
네.
한 번 더요. 자려고 sorry for some troubles on the internet problems. Okay, let's just continue briefly. Next is the warship acquisition process. Our country, the warship weapon system acquisition flow is like that. First, the requirement request in Navy and requirement decision in Joint Chief of Staff. And after that, DARPA and Defense Agency Program Administration, DARPA, and start the advanced research and establish the basic defense acquisition promotion plan and the midterm plan budget formulation and start R&D and two ways to development in my country or purchase another company or the foreign company, and they finished the prototype production. After that, mass production and first integration assessment and operate and maintenance for lifetime and disuse. This is whole life cycle of the from acquisition and disuse, whole life cycle of the ship weapon system. For this stage, they consider the policy and threat and mission assessment and alternatives main constraints needed there. This is the simple warship acquisition process. Comparing the commercial ship warship capability acquisition process is very complicated and long term, for about 8 to 10 years needed to finish the one ship delivery. The feasibility study, concept study, and basic design, detailed design, construction. Normally, the feasibility study is a Navy lead, and the concept study is the DARPA Navy lead, and after this basic design and detailed design, shipyard lead then. This early stage is very important because the many requirement of flexibility is needed. That this in the design stage, the feasibility concept studies takes about 2 years, and 2 and 3 years, and 3 to 5 years. Especially the initial design stage is very important, like just before. Even though the cost is small, design and the materials like that, design stages, the cost is small, but the influence is very big. Especially the concept design stage, the design flexibility is here. This stage is the many important requirement is freezing. And fast technology development. If we increase the risk by adopting the advanced technology or the cutting-edge technology, the designer and the ship constructor shipyard very more difficult to develop and more difficult to test, and compress the timeline and the compress budget. So more risk and higher cost. So normally the shipyard not willing to accept higher advanced technology because they face the more risks. But operating Navy always request to apply the new advanced technology in the ship. So some troubles between the Navy and the shipyard many times. And the warships, the cooperation system for warship procurement, there are several stakeholders to design and construct the procurement of the prototype ships. First, Navy carry out the ROC and concept design and TNA, testing evaluation. And next is the joint chief of staffs. They do the ROC and interoperability, and the DAPA planning, execution, and project managing, and ADD, and R&D support, and the shipyard, and shipbuilding, quality controls, and defense agency of the technology and the quality. And shipyard cooperate equipment system maker and combat system makers. All together communicate each other and some support. But sometimes well cooperated, sometimes not cooperated because they insist for own organization or the own company, they insist purpose. So for good warship performance, all stakeholders should be cooperate with each other. This is university. All students work here. The universities can study and can research many items with many stakeholders. And also, my student can find a job anywhere in the stakeholders. For your student also find a job here. So you can know the you can contribute to your capability to any stakeholders. Now we finished the warship design characteristics. Any comment or questions, student? Voice is okay? 한 교수님 잘 들리세요?
Yeah, sound is okay. Good. Quality is good.
Okay, if no questions, let's go next chapter to save the time. Okay, warship design trends. Enhance total ship survivability. For total ship survivability, first, reduce processability. Processability means the inability of the ship to avoid the sensors, weapons, and the weapon effect of the man-made hostile environment. To reduce the susceptibility, operational advantages, and reduce susceptibility, the signature control, stealth ship, and reliable self-defense systems. Next is the reduce the vulnerability. Vulnerability means the inability to ship to withstand the effect of the hostile environment, or what type of damages, how much the damages the ship can develop. To reduce operation advantages, zonal design, and optimal arrangement and protection against the hostile weapons. Finally, the enhanced recoverability after hit by some enemy's attack. Our ship is damaged. So enhanced recoverability, damage control, fire and flooding monitoring, and damage recovery, replace and maintenance. And in the severe conditions, if we discard our ship, which crew evacuation escape is needed. So 3 components should be considered to enhance the total ship survivability. For survivability, the radar cross sections. Radar cross section means some target transmit some radio electrical signals to our ship and reflected the radar cross section. So to reduce radar cross section, the 3 things. One thing is the shape of the ship. Second is the shape of the ship is some simplify and the flat plane is needed. Next is the inclination of the surface. For right angle of the surface, if the enemy transmit the radar signals and perpendicular to the face and reflect all 100%. But if inclined is that, if transmit the radar signals and reflect like that, so very low radar processing is needed. This is the without stealth design. This is the stealth design data cross-section signals. And reduce the infrared signature. Infrared means the mid-infrared and far infrared. Any object omit some infrared signals. So mid-infrared is generated from the funnel hot plumes, and the far infrared is the surface ship surface temperature. So by using the engine exhaust suppression system introduced, the mid-infrared signal is reduced, and if some cooling system of the spray system of by using the water, the surface temperature that it can reduce that. This is the without suppressed infrared signals and the medium infrared surface systems and the advanced infrared surface systems. So in the missile attack, beginning time missile tracking some radio signals, but finally homing by using the missiles homing through the hot spot of the funnels. And this far infrared is some needed for classification. And the next is the underwater radiation noise, reduce that. This is the engine, generator, and the motor drive motor, and the reducing jet propellers. These are propeller systems, but the main radiation noise is generated by the engine and the reducing gear and the propellers. So to reduce the noise, we can make the elastic mount and the absorbing shield, acoustic shielding, and the absorbing materials and the cavitation cavitation noises should be reduced that. And electric propulsion systems. For this is some hybrid propulsion system. This is the total electric systems. Hybrid propulsion system is the maximum speed, high speed is that they use the main engine and the reduction gear and the propeller. And low speed, they use some generator and the motor and the propeller. The fully total electric systems, they use from low speed to high speed, they use the generator and the motor and propulsion systems. This is for good advantage for power flexibility and reduce the underwater radiated noise and improve survivability. They also the shock proof from the underwater propulsion, near field explosion and far field explosion. Normally the ship designer not consider this near field explosion because if we consider the near field explosion, our ship structure is very heavy and strong, so weight is too high. So near field explosion is not considered during design. Only the far field explosion is considered. Far field explosion is the shock proof from the equipment, anti-shock performance. So we all the naval ship designer consider the far field explosion. And the integrated mast systems. This is the conventional mast systems and arrangement here. This is the new types of the this arrangement is that is the 잘 들리세요? 잘 들리세요? Okay. To the advantage of the IM integrated mast system is the minimum RCS IR signature. As you see, there are many complicated shape and interference here. So big RCS radar cross sections and IR signature here, and maximize the combat performance because this is the no blockage around the 360 degrees, all azimuth angles, the no blockage here. So, and increase arc coverage and improve maintainability. All sensors on the equipment inside the integrated mast, so they are not open to the seawater and the wind and the wind and the rain and snow, so to improve maintainability and reduce shipbuilding time because this hull form and integrated mast is independently manufactured at some different place. They after that plug in together, then we can save the shipbuilding time and improve the sensor durability and improve the EMI problem and save the deck areas. As you see, the very wide deck areas and the small deck areas here, and reduce top heavy. Another trend is the modular design for multi-missions. In the past, many navies build the new ships according to the each missions itself. For example, the anti-submarine warfare, they built the destroyer for anti-submarine missions only, and the anti-air missions, AAW warfare, and they use the another destroyers for the mission. But this time, in these days, the many navies, especially the very
not rich navies. They use the multi-purpose platform, and they carried out the multi-purpose missions. As you can, this is LCS little combat ship in United States. They carry out many functions of the missions. This advantage is the very cost effective ship design, because they 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 can use the multi-purpose design. Another trend is the combat system, the augmented reality and open systems, artificial intelligence aids. All together, this is the new combat system concept. Details are in here, so our student can read this quickly. And the unmanned and autonomy systems, as you see the pictures below, the unmanned surface vehicles, USV, and unmanned underwater vehicles, and unmanned air vehicles here. This is this anti-submarine warfare USV in United States, and the UAV and UUV. This is the nuclear-powered Russia nuclear-powered torpedoes here, and the Chinese AI unmanned submarine. Up to now, we briefly review the warship design trends. Next, we are going to some existing. We are going to some example of the new ship design trends. First, most advanced destroyer in the world, among the existing ships, the Dumalt class DD-1000 is a very advanced ship. Before the explain of the many things, let me see the YouTube